Okay, so I really don't like slideshows and PowerPoint and all these kinds of things. So while we're going through this presentation, if you folks have questions that are interesting to you, please feel free to interrupt. I believe that the most value we'll get out of this presentation is knowing what challenges or difficulties or questions you have, how we can perhaps address those. We do continuous integration heavily here at Puppet. We do CI with Jenkins mostly, but that's not the only tool we use. And we actually have a complete focus on automated testing. And I would imagine that's probably what most of you are interested in here. So if you have questions, please feel free to interrupt. I have left a lot of time at the end for a Q&A session also. And OK, here we go. So here at Puppet, so the team that I'm on is actually comprised of the people who actually package our software for shipment and the people who actually test the software. We're called the delivery team. And this is a really awesome slide that one of my colleagues made, actually for one of our conferences recently, to try to describe what people in our space do. What my mom thinks, of course, is they think we're doing this really crazy sci-fi stuff. When you say software delivery, people think, of course, like UPS. My buddies think we mostly hang out and drink beer, which sometimes happens. Coworkers don't really have any idea what we're doing, I think. So fuck it, ship it. The engineers think we're trying to encourage 100% quality, which unfortunately is not the case with software. And unfortunately, this last slide, it is actually a slide in my presentation. You can't really see it. It is a workflow of what it takes to do continuous integration, what it really looks like doing a full automated build cycle. And we'll discuss that when I get to it. So concepts of CI. So first of all, how many people here are actually using continuous integration professionally at the moment? A few people. OK, not many. Heavily or just getting started? Just getting started, yeah. That's, I think, where a lot of people are at. It's not really super easy getting started in continuous integration. Like the basic idea, if you're not already using it, you want to build like an automated building or repeatable testing pipeline, right? And your testing pipeline is progressively complex tests where you go from like simple tests like your automated unit testing, and you want to move up into then simple integration tests, then acceptance level tests, and then after that we run our full UI tests. And the whole point of this is to break things early and often and not spend a whole bunch of time testing code that's going to have to get retested because the build is bad anyways, right? And CI allows you to do this really well. If you really are going to try to get CI running at scale inside your company and really bring value, you need to have a collaborative effort. I have tried to implement CI at a number of companies. It's gone not really super well, to be honest with you, at most places. It's gone extremely well here at Puppet because we have buy-in from all teams. Our developers like it, we like it, and our operations teams helps us do it. And even up to our CEO is like, yes, this is how we will test software at Puppet. We have buy-in from the entire organization. Our team actually is really small. We are 3 people now. We were 2 for a long time. And we were actually serving 20+ developers. And that's just in-house. Then also community developers, since Puppet's open source. So we were able to provide testing for significant number of people. It's a ratio of like 2 to 20 or 3 to 20, which is really uncommon. Like most people, you have like a 2-to-1 ratio of devs to QA. So we have nothing near that. Here at Puppet, our devs, they own testing as well. So developers are actually involved in testing. It doesn't mean they sit around and do all the testing, but they write code to help us test their code. So they don't throw builds over the wall to us and say, we're done, bye. That does not happen. That does not work for continuous integration. If you are going to make this work, you have to have a development team that works with you, who is interested in making the code easier to test and develop and put into CI. Like I said, it's hard to get started. Start small, make some successes, and do it again. So what we test here at Puppet, a lot. And so, of course, I'm a geek, so I had to make kind of a matrix joke, which maybe some of you get, maybe not. So our testing matrix at Puppet is huge. Like, if we actually tested every permutation of browsers and OS platforms, code from 800 GitHub repositories. It used to be 600. Now we have like code in 800 repositories. Our software can be configured in a huge number of ways. So we have all these crazy test configurations. We have all these different browsers we have to support. We have a gigantic Ruby testing matrix, unfortunately. And then there's the various versions of our software: Puppet, Factor, Hyra, mcollective, standard lib. So this stuff gets tested on a daily basis. And that is a daunting task. So how do we do it? As I said before, we need to do progressively complex testing. We have unit tests that we run basically on, it's not every check-in, but we run unit tests on nearly every check-in, and we're constantly polling our software repository. So anytime there's a change in software repository, we automatically check out that code, kick off some basic tests. Depending on the status of those tests, then there's a pipeline of testing that gets kicked off, and they move on to more complex tests like integration level tests, which have some interaction with OSs. Then we have full-on system level testing, which actually takes like an artifact like an RPM or a Debian package or Solaris package or AIX and installs it on the operating system and joins it into a cluster environment and does a real application layer test. And when those things work, then we move on to do UI testing. And following that is, if we're in the correct iteration, we do scale-out tests. We don't do scale-out tests all the time. They are really expensive because we scale out to maybe 1,000 nodes. And we do that in EC2, and it's kind of expensive for us. So to make this work, how many people are using like SVN or Mercurial or something like that? Anybody using Git and GitHub? Oh, a number of people, cool. So for this kind of a pipeline to really work, you have to have fairly sophisticated use of your software repository. Like some of the software repositories I don't think really work as well. It's not a non-starter, but Git and GitHub really allow you to do broad scale testing, allow developers and QA people and everyone to be pulling from and adding to your repositories. So we use it heavily. And we are extremely heavy Jenkins users. We have a huge Jenkins environment. We originally had one Jenkins environment, which became super overloaded. And now we actually have somewhere, I've lost track, I think it's 5, but we plan to have about 12 down the road. And I'll go into why later. And also to make all this stuff work, we did have to write a custom test harness that allows us to integrate a bunch of pieces. And I will get into why a little bit later. So our CI ecosystem, like how all this works. Virtually all of our tests are automated. There is almost no manual testing that happens at Puppet. There are times at the end of an important release cycle where we ask everyone to install our blessed build and poke at it manually. That happens maybe once a quarter. But on a daily basis, we do not do manual testing at all, like literally none, right? So tests are automated. All of our builds are automated. So if the devs are like, hey, you know what? We need a new build for Debian or something like that, someone pushes a button. All right, and then we build everything. Or we could build all of our platforms with the push of a button. It takes a little longer than we want, but we're working on optimizing that right now. But you can get builds from a push of a button. And it is almost self-serve now, where we can actually just have our developers build an arbitrarily complex package, click a button, and get a build package for themselves. And our infrastructure is, I don't think it's 100% automated, but I'd say our infrastructure build out is 90% automated. So if we had a failure in our CI system, we simply rebuild the entire CI system by a small command line, shell script, right? Boom, and it will build out an entire infrastructure. If we have a new project that we bring up, we, within about 2 hours, can have an entire continuous integration environment ready for developers with literally us pushing a button and waiting for a couple hours for the whole thing to provision. So, yes? Sure.
What is the scope of your continuous integration?
Right. So okay, the question is, what really is your testing pipeline? What does it mean to continuously integrate? So, okay, the idea of continuous integration probably means different things to different people, but in essence, it is when you change code, you do a build and you do a test. A lot of places test on every single commit. That's a little bit expensive for people with 800 GitHub repositories, right? That we don't quite do that. But we do poll our repositories every 10 minutes. So every 10 minutes, we look and see if someone has committed to a repository. And if someone has committed to a repository, we say that repository needs to go through, at the very least, basic checks. The basic checks for us would be, we call them, they're spec tests, which are a type of test that you run on Ruby, but it is essentially a unit test, right? So obviously most of you are hopefully running some kind of unit test. That is the first stage of continuous integration, running your unit test all the time. Like our CI system is constantly running unit tests all the time, day and night, literally 24 hours a day. It's crazy. It's very busy. And we have, like, in fact, I think until recently, since probably people know, we've just got a bunch of funding, but until maybe 2 months ago, our most robust machines are the nodes that were running our spec tests. Like they had heavy CPU, huge amount of disk, and were able to handle lots of I/O. Right, so someone changes something in your repository, test. The pipeline part is if those tests pass, then what was just tested, is this a component of a larger piece, right? So if you're testing a web application and someone changed something on the database side, now you want to find out if that change has actually broken the whole stack, right? So there may be a integration level test that you do next, which would be like, I don't know, like load up some data into a database. Does the database explode, right? That would be kind of an integration check. If that passes, then the next step on the pipeline would perhaps to be install the application on a real stack, right? And again, this is automated. We have this automated here so that you could say, okay, spec tests pass, unit tests are good, integration tests pass, great. Let's go and build the whole stack, right? So building out the stack is way more expensive. You don't want to do that all the time. But if you've actually made it through 2 gates and you're like, we're good to go, then the next step is worthwhile. So it saves you all this time and all these people going like, oh, yeah, these emails come out. Some colleagues here from PolyServe years ago, we'd be like, oh, the new build came out, and then everyone starts pulling a new build and rolling out the new build into their environment and testing it, and then like 2 hours later, like, oh, critical bug, forget about it. All that testing time, all that manpower, it's wasted out the window, right? So this is what we're trying to avoid, right? And continuous integration will allow you to do that. You'll have to tailor the pipeline to your needs. But for sure, I don't know what your application is or what you guys are developing, but you do have some sort of unit level testing, I presume, right? So after you do unit tests, what would be the next step? What do you guys do after you unit test? Okay, cucumber test, right, perfect. So with CI, you can do that so that you could actually have, after your unit test run, say, okay, now it's time to run the cucumber stuff. You don't need people to do this for you, right? This is run on VMs, on real hardware. It doesn't really matter. Jenkins has the ability to run this anywhere you want. I'll get to some of those details later. So that's what you're going to be doing, right? Hopefully that addresses your question. So as our infrastructure grew and we realized that having one gigantic monolithic Jenkins was a mistake because people would go in and actually break it and go like, well, it would be really interesting if I like ran 500 extra jobs on Jenkins tonight and then blow up Jenkins overnight and wake up to a big mess. So we started breaking up our Jenkins environment into what we call Jenkins pods, and they are like a per team, per project basis. And because we've automated all this is really cheap for us to do. Like someone could come to me, we just have this new project, we have this new emergency thing that needs to be developed. We deploy them, a new test environment, off they go. It's isolated from everyone else. No one's stepping on each other's toes, and like an hour or two later, it's ready to roll, right? The one expensive thing that we had to do was a custom test harness. Not everyone will need to do this. Puppet is a complex product that needs to be tested on every version of Linux, AIX, Solaris, and Windows. That is a complex problem set. If anyone here has had to do cross-OS testing, you know that this is difficult. For that, we needed to write a test harness, and this is paid back, reaped huge benefits because the test harness is now integrated with Jenkins. It's integrated with our testing product. It's integrated with VMware. It's integrated with EC2, and has generic hypervisor support for AIX and Solaris. And when we get new platforms coming, we will be able to integrate new platforms into our test harness fairly easy because we've developed a kind of a pluggable architecture for our test harness. I know it sounds all super impressive and awesome, and you think, oh, maybe we can't do it. So I'm a terrible developer, and when I came to Puppet, I didn't even know how to use Ruby. I was new to Ruby, and we managed to do it, and it works, and it's awesome, and it's open source, and you can use it too. So we can talk about that later. Anyways, our CI ecosystem. So we have a vSphere cluster now that we're about ready to deploy. We are going to be testing on up to 500 hosts on that system, because when we fire off jobs in our CI system, we want to test the entire breadth of our product pretty much at once. Maybe not everything, but we would like to be able to test a lot of it simultaneously. And with Jenkins and all this work we've done, we will be able to test all of our OS platforms, configurations, and permutations pretty much in 2 hours, we hope, maybe 3 hours, versus right now, our test cycle is 24 hours. And it's killing us. It's actually really a hamper. So we've grown, and we're about ready to do our next step. We do scale testing in EC2. This is also part of our test pipeline, actually. And this is also automated, which is kind of a dangerous thing to automate scale testing because EC2 bills can get huge. So we spin up 800 to 1,000 nodes in EC2, all no hands. You pretty much fire off some code and come back usually a fairly long time later, like maybe 8 hours later, and you have 1,000 nodes going with our software installed. Everything's ready to go, and we're ready to actually do scale testing on it. This could actually be part of a pipeline. I wouldn't suggest you actually scale test as part of a pipeline because you go and send things off to do expensive stuff like scale testing when maybe it was a bad idea. So that we actually don't make part of our pipeline. We kind of fire that off manually, but it is, the code to do it is fully automated. And the last piece of our CI ecosystem, we've recently done this, and it's something I just talked to these guys about, is Sauce Labs, which is UI testing. So we actually have Sauce Labs also integrated into our CI system. So when we're done with all the system level testing and integrations, then we say, does our UI work? And again, this is all fully automated. Sauce Labs is an external service, but it actually looks through a concentration network concentrator. I don't know. Sorry, I'm not a network guy. Looks inside of our network securely, I'm told, and is able to see all of our infrastructure. And we actually are able to run up to about 20 parallel jobs on Sauce Labs. So you think all your browser combinations and your OS combinations, these are often done by like a slew of people sitting around doing it. Well, we have a slew of VMs out in Sauce Labs Cloud testing our UI for us automatically, which is super awesome because cross-browser testing is really painful and really expensive. If your company has browser testing needs and you're not looking at Sauce Labs, I really suggest you do. It has saved us a huge amount of time and money. So this is a interesting slide. Originally did this when I was trying to figure out what to talk about at PuppetConf, which is a conference that we host, and I was like, wow, that's really awesome. This is what we really do. And so I decided to keep it because it actually encapsulates the complexity of what it looks like to run a full-bore end-to-end continuous integration system. And this is what ours looks like, slightly simplified and only represents a slice of what we do, right? So to give you like the idea of the magnitude of it, like this would be like where our code lives out in GitHub in our repository. And every once in a while, when we're doing getting ready to do new releases, we cut releases and we push things out to our Jenkins master 1. And this goes to build control, which is a system that talks to GitHub and gets all of our code going, and then pushes all the code into our builders. And these are all separate VMs. These build tarballs and packages that wind up on our distribution server. And then our test harness, which is our custom test harness we built, which is also integrated with Jenkins, takes all of those tarballs from the distribution server and installs them on our VMware cluster, which right now is 60 VMs, but we are actively working on making that roughly 500. That's our capacity in the future. And this is actually a pipeline. I can show you guys more about this later. But we do very basic installer tests first. If the installer fails, there's no reason for us to go on to more rigorous tests, which are like system level acceptance testing. And if that passes, we go to our upgrade testing, which is actually a fairly painful and expensive process for us because we support very far back upgrading. So like very old products, we still upgrade. So this is, again, automated, all being done from our harness and Jenkins. Then we do uninstall tests, and if all that stuff is good, then we go to our UI testing, which is with Sauce Labs. Sauce Labs is outside of our network. And if things really go awesome, then we do a scale out to EC2 between 500 and 1,000 nodes, depending on what we're trying to investigate. All right, so this is what a real continuous integration system looks like, to give you guys kind of the idea of how complex it can be to do it end to end. Obviously, that's not what you want to start to shoot for, but this is where we wound up. And sometimes I'm amazed all of this works, and yet it does. So every day we do this kind of stuff. So if you really want to do advanced continuous integration, there are a lot of tools that you can get off the shelf, but it's not all going to be super easy. Not every plugin is going to work for you. Jenkins is not the perfect tool. Jenkins has lots of bugs. The plugins have lots of bugs. There will be some pain along the way, and there will probably be some coding you need to do. You will probably, as you try to advance your CI system, you will need either help from development or have QA people who can code or have a developer and test. Otherwise, I think that this becomes a fairly difficult task. So we actually wrote our own test harness that actually integrates a lot of the pieces. So it's configuration driven. So if you make a config file, it's YAML based, and the more nodes and hosts you stick in the config file, the more complex the tests will get. So if you have a very simple config file with a single host, then you get like a single host test. If you put a whole bunch of nodes in the config file, then when the test harness fires off, it will spin up VMs to satisfy the requirements of the config file, run your tests, off you go. I thought someone had a question. I saw a hand popping up. No? OK. Like I said, we have vSphere, VMware Fusion, EC2, AX, and Solaris hypervisor support. Unfortunately, the plugins in Jenkins that talk to these environments, they are probably better now, but we abandoned them at one point because they would break, and having something like your continuous integration system go down because a plugin breaks and you can no longer talk to vSphere or you can no longer talk to EC2, that is really not OK. Right? So that is actually something where we're not going to rely on certain parts of Jenkins anymore. The core Jenkins is fine. Some of the plugins are not. And this is why we did our own hypervisor integration. It's not as hard as it sounds, actually, but lots of stuff about how to do it on the web. And this harness also, even though you have like a CI system, Jenkins will not solve all the problems of how to test your software. It allows you to automate your tests. And since we have a very special product, we had to actually write our harness had to have code to allow us to test our code. And very likely, most people will need to actually implement some of your own testing code that way. Some people use Cucumber or other off-the-shelf tools. We found that we needed something more custom. That's what we did. It's worked for us. Our test harness is very low impact on the target system because we don't want to be running our testing tools. Like a lot of test tools, they want to install on your test target. And this is really not an optimal situation. So ours is client-server based. So Actually, our harness talks to our nodes under test and does the test remotely. There's not a CPU or memory impact. And it is cross-platform across every Unix and Linux and most Windows platforms. So, and this project started about 2 years ago, and it actually grew with us as we did our continuous integration system grew, our harness grew. We actually have people in the community now who actually use it and do code to it. All of our developers use it. Well, most of our developers use it. All of our QA team uses it. So it's kind of cool. So getting started on CI, there's a lot of pitfalls. Some of the things to avoid would be use something that's easily supported like Jenkins. There's many options. You can use Bamboo, Test Runner. There's a lot of platforms out there. So Jenkins is free, which is awesome. It has a really awesome community support and a really active IRC channel. All of the CI systems have warts. We've evaluated quite a few of them. Many of the commercial ones that are really expensive to implement. Sometimes you're talking like over $100,000 to have a proper CI system from a commercial company. They don't really do much more than Jenkins. They have a slicker interface, but Jenkins works for us at scale. So start something simple like Jenkins, see if you like it. If not, go somewhere else and look for Bamboo maybe. You should really have some sort of automated test appliance or infrastructure rollout stuff. So part of having CI work is to have your test environments clean and not expensive to set up. So you don't want to have a bunch of QA people spending their time building out test boxes all the time, because this is what a lot of QA people do. They become like the second ops team, right? Oh, okay, we're in between releases, so go and like re-kickstart all those machines and fix the network, and so that doesn't work, right? So automating your test appliance configuration and some infrastructure stuff is really recommended. It's not really that hard to do. It'll make you guys a better team and a better company. I recommend you really do that. And start small with something super, super easy. Like choose the simplest unit tests you have that are already automated, that people are running like maybe manually, or you have some shell scripts running cron jobs or whatever, and put those into CI and run those for a while, right? And then when people see how easily you can extend tests and say like, wow, okay, I have those unit tests. Oh, now I want to run those unit tests on that other platform, and it's literally like adding another tick on a box. And now your tests are ran across multiple platforms, and then across multiple browsers and all that kind of like, wow, this is actually really working for us, right? Do a skunkworks project on it. This is what we did. Go and do it in a closet. Don't tell people what you're doing, and then say, hey, look at this cool thing we're doing, and people will adopt it. Yeah, integrate auto tests, and yes, help. So one thing I noticed, I've actually engaged with quite a few companies here in town and talked to like some of the engineers and my friends who I've worked with from former startups. Management people seem to be reluctant to call in outside people for help. And maybe I'm spoiled because I work at an open source company now, but when there's people locally that we know, people from out of town that we know that have expertise, some of them will actually come to our office and help us for free. They don't want anything. They're just like, I want to take part in helping you guys make your stuff more awesome, right? Ask for that help. On IRC, there's huge amounts of resources for Jenkins and continuous integration. There's all sorts of local meetups here that are willing to do this kind of stuff, and we're willing to do it. So if you're a company and you're here local and you want people to come and help you get going on CI, we would come. One of us on our team would come and hang out with you guys, talk to you about it, show you, like really sit down with you and show you, look, this is how to get started on CI, right? So don't be embarrassed to reach out and ask people. Okay, wow, that was kind of fast. Questions, Q&A, please. Yes?
The first slide you mentioned, collaboration of 3 groups, devs, QA, and ops. Can you define what your operation, what you meant by that?
Yeah, sure. So we have a heavy load on our network, and in fact, of the consumers in our office of our internal infrastructure, the QA team is the largest. It is more infrastructure running QA than to run entire Office for Puppet, by far, like by a huge margin, right? So your ops team is going to hate you, so get in front of the problem, right? Because you will need network resources, you'll need servers, you're going to need virtual machines, or you're going to need EC2 stuff, you're going to need network stuff, firewalls are going to need to be opened up. So you need to engage with your ops team so they are not like, wow, those guys always ask us for stuff and it sucks and all that kind of stuff. But we had that problem at first. Yeah, we did. We have solved that problem by actually embedding a person on my team he's a QA hire, but he's 100% dedicated to operations. And this was an awesome move for us, but we were willing on the QA team to say, all right, we have a head count for a senior level person, senior level compensation. Are we going to hire a senior QA guy? Are we going to hire an ops guy to help our ops team kick ass? We're like, we're going to help the ops team kick ass. And that was the right thing to do. And this has helped tremendously. This is why we're able to get a VMware infrastructure up to 500 nodes soon instead of 60 that we're breaking a lot. Because I'm not a VMware expert, and none of us were. So, yes? We do some monitoring, and the tool is, pardon? Oh, sorry. How do we monitor our continuous integration system? So there's various ways we monitor continuous integration. So I think we have somewhere in the area of 500-600 jobs running in Jenkins. I don't even know. It's really kind of like the Wild Wild West. We allow developers to add their own jobs, so I don't know the exact number, but there's a couple things that happen. When tests fail, there's emails sent out, right? And they're sent out to particular groups. But if you're talking about like monitoring infrastructure, then the way we monitor infrastructure is with like Graphite and, oh God, what's Nagios, thank you. Nagios and VMware. For our VMware stuff, we actually have some, VMware has like an interface to like performance metrics and all and it has alerts and things like that, so we use that. But yeah, we use off-the-shelf like open source stuff mostly. Yeah, so the question is, with our scale testing, do we do performance and load to fail? And the answer is yes, we do. We load the system until everything tips over, and then tune and do it again. So yes, that is exactly what we do. The rolling out of the infrastructure for our scale test is the part that we've automated. The actual running of scale tests at the moment is not really automated. It's not really automated. We do point our test harness at it and start running different tests and have things go load up our systems. But that entire process is not all the way automated, which is fine. For scale testing is so kind of special, and you kind of need to watch what's happening to really see what parts are failing. And it's a little bit hard to instrument something, a 1,000 node environment. So there's a little bit of hands-on with that. It's something we're working on improving though at the moment. So Pierre?
Can you talk about email and the reporting? Because it sounds like you guys got a lot of jobs running. So you come in the morning, or people they look at Slack, what's going on?
Right.
How do you make sense of all this stuff?
That's an excellent question. If you go and look at, I'm going to actually see if I can. I'm going to actually, if I could find the mouse here, I'm going to bring up our production Jenkins environment. And, the question is, how does all this reporting stuff really work, right? Like, how do you handle the email and all this kind of stuff? So the thing is, these are jobs, as you can see at the top. These are like some of our different projects: Puppet DB, Cloud Provisioner, Dashboard Factor, on and on and on and on. As you can see, the tabs are huge. And if you drill down into any of those jobs, you'll see that there's many jobs underneath. And underneath those, there's yet more jobs. So there's a huge number of jobs here. How we handle that is, for example, these jobs here, what I'm looking at is our Puppet core project. That emails the core developers who are on that project when it fails. We don't necessarily email everybody, although we do have a Google group for continuous integration that I think does mail everyone, but you have to join that group. But there's specifically targeted groups. So if you're part of the core team, you'll be on the email list for this project, and when it fails, you will get an email about the failure. And when they pass, we have it set up to not email on passes because there would be like really too many emails. But it is a huge volume. But the way you solve that is simply by configuring the jobs to email the correct groups during failure. Man, it's not super exciting, but a job configuration in Jenkins looks like this, and yeah, there. So this actually does email our continuous integration group. So that actually goes to our kind of like our broadcast group, but it is set out with a title about what job failed, and we are careful about the way we've named our jobs. They actually have a namespace that makes sense because everybody filters the jobs based on the names. So you actually, is one of the things to organize with your team is to make sure that you name the jobs so that they're sensible so people can filter this stuff because it is thousands of emails every day, right? So lots of hands. Over here. Okay, how long is our delivery pipeline? When you say that, do you mean?
The time it goes Checkin to when you guys actually release it, or the market is ready to release?
Sure. It depends on what project you're talking about. So like for our Puppet project, the delivery pipeline, like if you're just talking about like a core Puppet, like our core code, a release could take, I don't know, maybe a couple of hours, right? It's fairly fast for that. For our enterprise product, which is actually much more complex and has Windows support, AIX support, Solaris, a web application, and all these other pieces, we can do a build in about an hour. We can do basic testing in a couple of hours, but to do a full broad scale release to test all platforms, all upgrade paths, UI, and uninstaller tests, like I said before, is 23 hours. We just calculated it today. Our goal is to have that reduced to about 2 hours. That is where we're trying to go for. So from almost a full day, 24-hour cycle, to a 2-hour cycle. And I think we'll actually accomplish that. It's not unreasonable.
So do you have anything that controls so that your tests don't run on top of each other? So the next
Yes.
that comes along?
Yes. Jenkins, the question is, how do you prevent tests from stomping each other? So Jenkins actually manages this itself. So Jenkins will not fire off another test. It will prevent that. If it's looking at a target, there's testing queues. If you look on the side over here, these are test machines. These are some nodes where we have an EC2 that are for our spec testing. These are coordinator nodes, all these different things. So these are actually these slots that have idle next to them. Those are areas where we could have a job loaded up and running actively. And the Jenkins system is smart enough to know not to clobber one another based on some heuristics and based on the jobs. When you set up a job, you might say, for example, this test requires a node like the EC2 node that has, let me see if I can get some information on it. Hang on for a second here. Its description. If you look at the description of this box, it's actually, no, that's not what I want to look at. Hang on, give me a second here. Sorry, this is an important question. Give me 2 seconds here. Manage Jenkins, and hang on. Wow. There we go. Manage nodes. Okay, sorry. This tag here called labels, this actually describes this test target's capabilities, right? Those are actually meaningful tags. So when you have a job set up and the job says, I need Ruby 187 and I need RVM and I need it to be an Ubuntu 10.04 node, right? So they'll be like, okay, this node matches those descriptions and it will make sure that there are open test slots on it, and then it will go and fire off a job in there. And if that system is too busy, it will then build up in the queue up here. If you see this build queue right there, if you see this node right here, or this job right here, is waiting for slave 10 Puppet Labs land to be back online, right? So we have a node offline. So this is what will happen to your jobs when they wait for resources to become available. And as soon as the resource becomes available, this job will automatically get thrown into the queue and executed. So it's kind of happens automatically. There was another question over here. Yes.
What event triggers the either addition of new integration tests or the ending of existing integration tests? Have the developers aware that they did a function code change, and they're aware of these tests that be changed, or you run it very different?
Right.
Test-driven development.
Right. Okay. So the question really is, when there's a code check-in and that kicks off tests, how do you know that the tests being run take account for the code change? Is that correct?
Yes.
Yeah.
How do you
Okay.
know that tests that are out there that
Right.
where tests will break and have time to just wait for them to break?
Oh no. Okay. So the whole idea of continuous integration is that, depending on your code coverage, let's assuming you have fairly good functional code coverage. The whole point is you don't need to know up ahead. The point is let the continuous integration system find the breakage, right? That is the point. You make a code change. Hopefully, like the developer is running maybe some unit tests on their laptop or however they have their own development process. But the whole idea is check in that code, it breaks, back it out, right? And if you're using real TDD, then when you're pushing new code, you should be pushing tests as well, right? And if you're familiar with GitHub, or Git rather, and the way GitHub works, the tests live together in the repository. So you're actually committing code to our core product, Puppet, but then you're also committing your tests to the test repository that's actually part of the core repository. So when we do a checkout for code, you've added new code, but you've added new tests. So now when you go and do a checkout, you get the new code, you get the new tests, off you go. And a lot of what CI is actually is running regression, right? You are running huge amounts of regression tests. And this is actually part that's, I think, one of the most valuable part. Regression testing is expensive. It is horribly time consuming for human resources. And it's super cheap to do with computers, like really cheap. And if you write decent code, decent tests, it's really worthwhile. And it pays in spades for us because, like I said, we have about 3 QA people and we have 20, I think we have roughly 25 developers now, and we take code from the community as well. So with that number of people, we're able to do testing at the scale, right? The question is continuous integration part of the unit tests? I don't think that's the right way to look at it. Continuous integration is an engine to drive your unit testing in a repeatable, reliable manner. And it's the beginning of a larger testing pipeline where you go from lightweight, easy tests like unit tests to more complex testing like integration and acceptance and UI testing. I don't know if that answers your question or no. Okay, you can ask again. Sure.
Can you tell us about any defects that may have gotten into production that this didn't catch, or possibly that you came back and said, oh, maybe there's a hole in here, we got to fill that in?
So the question is, anything that has slipped past our CI system, and the answer is, of course not. Our CI system is perfect, as is Puppet. So no, yeah, I mean, naturally it has happened. This is an excellent point. This is not a panacea for everything. Like if you do CI and you're like, someone was saying earlier, like, yeah, you do CI and you think you're all going to go home and be at the pub. Yeah, I wish, right? So one is new features. If you are not writing new tests for new features, CI system is not going to help you. It only tests the code that you're putting in there. Poorly written tests, yes. We occasionally, if you are watching our blog, we have had several CVEs out recently, and those happen. And security is a poorly understood part of software still today, scarily. And these things get out into production. And what do we do about it? Yeah, we fix it, and we write tests around that. Security is not a really easy one, but there's other faults that get out sometimes, and it's mostly edge cases, actually. Our core Puppet, like we don't get those kind of bugs anymore where you're like, okay, this software just doesn't work. And this is not a joke. When I started Puppet a little over 2 years ago, we were a very small company. We were like 20 people. We would have releases that would go out into the community, and it did not work on like CentOS and RHEL because the developers were running Ubuntu on their laptop, and well, it worked on my laptop, so it must be okay, right? So we never have anything even remotely like that anymore. We test across every platform in a real manner, out of real packages, on a real OS. We do not ever have that anymore at all. We mostly have small edge case stuff, and that is an awesome place to be. It took us from people thinking our software was really crap and unstable, because it really was unstable. It had really cool features, but was often not usable, to being now extremely reliable. Puppet does not really break anymore, which is kind of awesome. So, questions in the back?
I'm just curious if you are starting to see more folks in the community doing CI around their modules, not Puppet itself.
Yeah.
It seems like that's a trend, but I don't know if
Yeah, so do you know the question is, do we see the Puppet community doing CI against modules? And the answer is yes, not as much as we would like, and we are actually working on extending this kind of an infrastructure for the Forge. Do you know the Puppet Forge? Okay, so that the Puppet Forge will allow people to submit modules, and then we will run a module through the CI system and report back good to go or breaks, and actually have it in like a queue, and so you can watch your module submission. So that's something we're actively working on. It's probably not the highest priority, but it is actually something we are currently working on. Yeah. More questions? Pierre?
Talk about the pods, and I'm new to Jenkins, and we use that in our environment, and you can have jobs trigger some other jobs, they can trigger some other jobs. So can you do that with multiple pods as well?
Yes.
Can one pod come together?
Yes, sometimes with difficulty. It is not super transparent how to do that, and super clean. Oh, sorry, apologies. Can multiple Jenkins instances pipeline together so that you can actually have one Jenkins job on a given node fail or pass, and then kick off another task? And the answer is yes. And it's not super clean and super easy how to do that. We are actually working on that right now. We do have some of that going. There are many, many plugins that claim to do this, and we are currently evaluating the ones at the moment that suck the least. And we are finding some pain spots there, but they generally improve, or we may even make our own plugin for it. It's not super complex, actually. So, Daryl.
How did you get, when you began, how did you get the development and QA teams together to get started on this?
Okay, the question is, when I started Puppet, how did I get the developers and the QA team together on this? This is a really good question, because it is, if you don't build these ground support for this, you will never, I don't think you will be successful in this. So there's a couple things that worked. One, I started when Puppet was really, really, really small. I was embedded on the development team. I was part of the development team. I was treated like a developer. I wasn't like, oh, that QA guy. That's one thing. Our CEO, who is the guy who actually wrote Puppet originally, completely backed up what we were doing. It was like, this is what we're going to do. Most of our developers were actually on board with this. And when I first started writing our test harness and doing some of our initial integrations, it wasn't really so good, to be honest with you. But our developers are kind of awesome. They were like, oh, all right, this guy needs help. We would actually do full iterations, full sprints that we dedicated only to working on testing tools. The whole dev team would be like, okay, we're gonna like fix the logging in the test harness. And they would do like crazy code stuff, and I'd be like, wow, okay, man, my Ruby is really bad. You know, they just really like completely fix huge portions of our test harness. So what they could accomplish in a 2-week sprint, I mean, it was ridiculous. It was humbling, right? I mean, it was truly humbling. And then we'd use that for a while, and then we'd be like, you know what? We need to do another testing sprint because some things are not working, and we need to get things going. And this is the time when I was the only QA person. All right, so we were probably, I think we were like maybe 15 or 18 developers then, and it was just me. And they were like, yeah, we're going to totally help this guy. And they would totally dig in. Engineering resources were allocated. Time was allocated. Engineering managers, again, up to our CEO, was like, yes, let's fix testing tools. Let's make an awesome testing environment. We need that for Puppet to go forward. And that is really how I got the buy-in. And just working with them and working with the ops people too. I just go over to the ops people and say, look, this is going to come, whether you like it or not. I'm promising you this is coming, and it's from your boss, and so this is going to have to happen. So let's like make this stuff work for the operations side before it becomes like this huge fiasco for you guys, right? And they're like, yeah, okay, awesome. Let's totally fix that stuff. So, yeah. In the back, Lorraine. Sorry, louder. God, so the question is, when I first was getting into CI, what was the ratio of devs to QA? And it was 1 to everybody else. For a very long time, I was the only QA person at Puppet, which was a little bit hard. I have an awesome QA team now. They really kick ass. In fact, they're kind of back there. They're really awesome guys. But yeah, I was like swimming by the time they finally hired other people. And a lot of stuff was not optimal at that time because we were kind of understaffed. Puppet really was operating as a lean startup then, which I support. I'm like, the don't spend money guy. So I was actually okay with it. Kind of started to suck at a certain time, but it was the right thing to do. And to be honest with you, I think we did the right thing. We were really careful on hiring QA people. I've interviewed a lot of QA people, like huge numbers of QA people, like I don't know, I can't even count. It's like probably like 50 or 80 or something like that. And there's a particular attitude that some QA people have, and mind you, I'm a QA person, so I'm not poking fun at them, where there's this adversarial relationship between QA and dev. Like, okay, that simply is unacceptable here. Like, that is totally unacceptable. If I have detect that in a phone screen with someone, it's done. It's over. I will not even bring that person in for an interview. It sounds kind of maybe a little bit tough, but our developers have bent over backwards for us to help us on a lot of stuff, especially when I was just one QA guy. So we make sure that we keep the culture clean and we don't get these barriers building up between each other because it doesn't work. Like, for example, my QA guy right here, Justin, who won't raise his hand, right there, Justin. He's a good guy. Justin's awesome. So Justin is actually embedded in a development team. So I hardly ever talk to him, right? He just comes in, drops the stuff off, and he goes over to the core Puppet pod, which is where our core team sits. And he hangs out with them, and he works with them on whatever it is that's their problem for that day. So if they're having infrastructure woes, he helps them with infrastructure stuff. If they need tests written, he helps to write tests. He doesn't do it all for them. I mean, like I said, developers also write tests. But he sits down, he educates them about our test harness. He shows them how to integrate jobs into Jenkins. He helps them debug Jenkins failures. In this case, he kind of belongs on that team, and they treat him like a team member. And that's kind of the model that we use right now, is to embed people on dev teams. And it works out kind of awesome. So, you. Right. Okay, so the question is, how much of getting to a big CI system like this was like really cultural and changing of internal processes or technical hurdles? There was cultural barriers at first, and it was not so much against CI. Like our team was actually really happy about doing CI because like all good developers and all good tech people, we are essentially lazy. Otherwise, we probably wouldn't have jobs where we sit all day long. So they were like, yeah, awesome. We can just push our code and it automatically gets tested. Awesome, right? But there was a lot of developers think about the way code works in an ideal world, how it works kind of in a simulated world. Where I had pushback was actually getting us to do acceptance level type testing, where you really install a built artifact onto an actual operating system and test our code in like a real world scenario. That was a difficult task actually to get them to do that, like really difficult. Acceptance testing is time consuming and it is expensive and it is absolutely necessary, right? And us not doing that is why we would ship a release that would not run on Red Hat, right? And so we solved that problem, but it took some time, and it took. I'm stubborn, and I really stuck to my guns. I was like, no, we are doing this kind of testing, and we just kind of stuck to it. I think as people see things working, when they're like, wow, okay, our releases actually work, and people like our software, and we don't have these emergency firefighting sessions where we're like, oh man, that new release doesn't work on 3 major OSs, and when that stuff goes away, then people are like, okay, this is working, right? So this is when I said to start small in CI, is to show people that this actually brings value to them, the developer, to the QA people, to the business organization. You can actually see what's going on. You always see the status of your builds. People can see how long things have been failing, how long things have been stable, all that kind of stuff. And when they see that, you get past the cultural problem. So there is a question over here. Yes. Yeah.
How well does your system support code branching?
Okay, question is, how well does our system support code branching? So we use Git, and I don't think there's another code management system that has anywhere near Git's branching capabilities. It is the best.
Is there a lot of moving around with integration tests to make sure the appropriate tests for the test the correct branch? Is that all managed by Git?
When you branch with Git, the tests that are actually there follow the branch. So if I take our core repository and I clone it and I go and do some work on it, when I integrate that, if I test that branch individually, or even if I integrate that back in, the tests that were there, they follow the branch, no matter where that branch goes. We could have 1,000 people check it out, and everyone will get the test as well. And when they check that back in, their code back in, if they have tests that were added, then those tests become part of the repository. So this is, Git is I actually can't imagine functioning in a CI system without Git. When I came to Puppet, I was a SVN user, and I liked SVN better than CVS. And now, and I actually, Git was really a little bit conceptually difficult at first, and now I literally cannot imagine using anything else. If your team is not using Git, I genuinely believe that you are making a core mistake in your company. I mean that, it's not a joke. All right. So, sorry, this gentleman here in the back.
Do you integrate with other tools like Maven?
Okay, the question is, do we integrate with Maven? Maven is actually kind of like a core part of Jenkins, actually. It's part of the core of it. We don't use it, but Jenkins has like out-of-the-box support for Maven and Ant and like spec testing. It's like all these kind of like normal unit level tests that you would normally have. It's out-of-the-box works. We do not use Maven, but you can use Maven with Jenkins, no problem. Absolutely. So, yes.
How far upstream or downstream can a branch make it? Like, so someone has a feature branch they're working on. Is there some point where you run the unit test, but it doesn't try to send it all the way down to release once it's merged in, or how does that?
So there's a couple ways to approach that. So the question is, how far downstream or how far detached can a branch be where it then gets back into CI, I believe is what the question is. Is that?
Yeah, well, I'm wondering, so you might not want a branch to make it all the way to scaling testing.
Right. Right.
So how far can a branch go in your CI environment?
Right. Okay.
Or it needs to be a master?
Got you. We gate at like the unit level test. If unit level tests fail, then the branch is dead. Yeah, you fix it first, right? So it actually stops at the unit level. Unit level must pass before a branch can go down the pipe. In fact, that's kind of really the entire pipeline works like that. If you fail at any step along the way, then that's kind of like, okay, you stop, right?
But a branch can conceivably make it all the way to scale?
Yes. Yes. By the time we get to scale testing, we're at packaging. We fully package by then. By the time you get to where we're going to do a scale test, we don't use Git anymore. We actually have said, so this is so close to being a shipping product that we are going to roll the Debians, roll the RPMs, all those kind of, and actually install off of out of real repositories versus out of Git. Because it's so expensive to do a scale test, you want to make sure that somewhere you didn't blow up your packaging system and then go like, oh wow, so now we have to repackage and redeploy, right? That's too expensive. So.
Around how you use a branch, maybe you do local branches until you're at a point where you want to push it out.
Right, right. That's correct. I saw some other hands. Yes.
Do you ever release the branch or only from
We release, we have some long-lived branches that we've used in the past, but that's something that I'm sorry, the question was, do we release branches or do we fold back into head? Puppet's way of doing development is that we release off of a long-lived topic branch that's off of our stable master. So you have if it's Puppet 2.7, then you have the 2.7 master, which is the stable branch. Then you have a long-lived branch that's 2.7x, we call it, and we develop on that until that is where we want it to be. It goes through all of its testing. When it's good to go, we give it it becomes an RC, and once the RC is good to go, then that is folded back into our master branch. So they're long-lived. Yeah. Questions? More? Yes.
Looking at the bigger picture, what do you see the future of CI going in the next few years?
That's an excellent question. I actually believe the time is right for Jenkins to be majorly redone or replaced by something. We use Jenkins seriously heavily here, and I don't want to be like, oh, we're like the experts, but we seriously push Jenkins far, and we're like, wow, there's some stuff here that's painful and not graceful and kind of complicated. I think it's time to go somewhere else with something, get rid of Jenkins and go to Jenkins version 2 or something along those lines. I don't really know if that's going to be Jenkins or something else. I think Jenkins is a little bit long in the tooth. I think that you're going to see people using, it's funny, I heard people talking about the cloud when I came in here first. Like everyone here is cloud, right? And it's funny because some people are afraid of cloud space stuff, right? I don't know why. So what I really believe is that you're going to see people using cloud heavily, whether they're actually running their CI system in the cloud or the CI system actually lives locally and then their testing environments in the cloud. Like when I talked about our VM environment being able to run 500 plus nodes, we are building a miniature cloud in-house. And the reason why we're building it in-house is for all sorts of reasons. One is performance. We are a DevOps company. We eat our own dog food, so we should be able to bring up a large cluster and keep it going. That's part of our look at what we can do. But using the cloud for testing has been awesome for us. So for how many of you have a UI component, like a browser-based UI component to your product? Like almost everyone. How many people are using manage your own test environment? Like you manage VMs, like Windows boxes with IE and all that kind of stuff. Yeah, way too many, right? Okay, so we did that too at first. And it was a complete disaster because we were a small team, as I told you before, and we were trying to spin up Windows VMs and different versions of IE, and how do you manage all these different versions of IE? And no one at Puppet knows how to use Windows because we're all Unix hackers, and it was just it was a total nightmare. And I think we burned about 3 months with one guy sitting in a corner trying to make all this stuff work. And he was just I think he's still, I think he's in therapy still, right? So we literally took that system and just shut it off. We're we are never going to ever resurrect that thing ever again. And we went to Sauce Labs, which is a cloud-based hosted UI testing service that is absolutely, it's seriously phenomenal. It took me, I think I was able to get our entire UI, a proof of concept of having all browsers on all platforms running against our code. It took me maybe 2 hours, right? That means I was able to spin up Windows VMs with IE, Firefox, Opera, Linux boxes with Firefox, crazy browser combinations with seriously maybe 50 lines of code. And it took me 2 hours, and I'm not even a really awesome developer. So this is clearly where that's going. UI testing as a service is absolutely phenomenal, and we now use it heavily. So I basically went to our developers and was like, wow, look. And they're like, really? Awesome. And now they're just they're like, could you please give us accounts on that? I gave them accounts, and boom, off they go. They're totally using it. And for example, another thing that we do with Sauce Labs, if you need to do some manual testing, you need to have someone fire up a browser and point it at an application and do some debugging. You just log into the Sauce system and say, okay, I need to do some manual tests, fire up Windows 2008 with IE9. 30 seconds later, you have IE9 sitting in front of you, and you're testing like manually. And when you're running your automated tests, it actually takes a video of your tests as they run. And if you have like a failed test, you can go in and find the failed test in the web, your company's portal, and you click on it, you play the video, and you're like, oh, awesome, there's the failure. Or if you have like a persistent fail state that keeps happening, you need to debug it in real time, you let the tests run, and while it's running, you can actually watch the tests running, and then you can click on the browser, and then all of a sudden your tests are halted, and you can now take full control of the browser and start poking around and like do like, okay, what's the state of the browser? Why did this happen? I mean, it's seriously, it's like unbelievable. And we're like, wow, I wish we'd have known about this 3 months before. So if you're not using something like that, you will. I really believe that. Oh, okay. So what is the cost on Sauce Labs? It is absurdly cheap. I think we pay $200 a month, or I mean, it's not even beer money, like literally, right? It is. In fact, the Sauce Labs people, we were kind of early using it, and they're like, well, what do you think about Sauce Labs? And I'm like, well, you definitely are underpricing it, right? The cost to maintain a stack of VMs with all of that stuff on it, I don't, I mean, it's huge, right? And seriously, like $200 a month, I think buys you like something like 1,500 hours of testing or something like that. It's in their highest tier, I think is like, it's just like unlimited hours. I think it's only like $500 a month. I mean, it is cheap. It is dirt cheap. So I saw some hands popping. Yes. What do we use to maintain our test data? We use GitHub. Everything at our company is in Git. Documentation is in Git. Executive stuff is in Git. Everything is maintained and versioned in Git. Everything. If GitHub goes down, we have problems, right? So, and that has happened. We're like, well, nothing works in the office when GitHub goes down. Like seriously, everyone uses Git. Our documentation people, they version their documentation using Git. We teach our developers our documentation people, we show them how to use Git and GitHub. So everything is maintained in GitHub. Yes?
How do you handle cascading failures in
In terms of reporting?
Yeah, when you have a failure in Jenkins build, and there are several things, that do not see,
Right. Okay, so the question is, how do we handle cascade failures? It depends. That really depends on the job. There are some jobs that we gate and say, if this upstream job fails, or if this cell of a matrix of jobs that are running fails, then don't continue any further, right? And then some were like, actually, we don't care. We really want to see the full breadth of the tests being ran. So this is really it depends on the project. So for example, if you are testing across platforms, you actually generally want to run the test against all the platforms because it may only fail on one platform. So those we go into. If you're running something like spec tests are below the operating system level. If a spec test is failing, a unit level testing is failing, probably you should just stop right there. And that's actually kind of how we handle that. That's really a business decision. Depends on what kind of software you're developing. It would be different if you're doing file systems or if you're doing like a web app. So I saw some other hands. Yes, in the back.
You talked a little bit about having needs set for, say, Jenkins 2.0. So what kind of vision do you have for that? Or are you just kind of at the point where, well, such a change in configure, and my God, they should have made this easier, let's roll again?
Right.
Or do you have a vision for it?
Yeah, yes, this is a great question. So the question is, what is it that we envision would be better with a different CI system? Why are we having problems with Jenkins? What don't we like about it? So one thing about Jenkins that's a little bit, I think maybe confusing and bewildering is the entire system is an entire gigantic XML tarball, right? So Jenkins is totally configured by XML. So you can't just like dump a database and get information about your tests out. That's one thing. So the back end is a little bit old. So when Jenkins starts up, it reads a gigantic XML structure and loads all of that into memory. And as you get really big Jenkins environments, then this becomes actually kind of time consuming. And you guys, anyone who's done like XML parsing knows that, if you have like a massive XML data structure, which if you look at what we have here, we do, including if you look at the jobs history and all this kind of stuff, right? Like all this history, it's a huge amount of data, right? So that's one. Oh, the Chuck Norris plugin, yeah, right. That's one of the plugins. That's why we use Jenkins, of course, for Chuck Norris. So that would be something that'd be cool if we had actually more sophisticated configuration management in Jenkins. It would be nice if the plugins were curated so that you could actually get plugins that you know at least don't blow the system up. There was a time when someone in management was like, hey, it would be really awesome if you got me some statistics. And I said, okay, cool. There's a plugin in Jenkins for that. So I installed the plugin, and it blew up our Jenkins environment. This is during like one of our enterprise testing cycles. So all of a sudden, our entire Jenkins environment was just, it totally went sideways, right, from a plugin. That's suboptimal, right? That is something I'd say needs to be fixed. And the Jenkins like ecosystem, if you go and look at Jenkins plugin page, I don't know how many there are. It's in the many hundreds. There's many, many, many duplicate plugins that kind of do the same thing. The descriptions are poor, and their behavior is yeah, hit and miss. That'd be something. And inter-Jenkins communication is somewhat difficult, and advanced pipelining of jobs within Jenkins is not super awesome, to be totally honest. I mean, it's good. We're at, I think, the end of the ability to pipeline in Jenkins, where we almost need a tool on top of Jenkins. But that's, evaluating and adopting a new CI system is seriously expensive. So we've kind of looked at some other ones like Bamboo, which actually has a really nice interface. It was easy enough to set up. We did a real POC on it. We started doing things with it, and we're like, wow, that was really easy. But this other thing we need to do was really hard. And so we're just kind of trading off bright spots for other hard spots, right? And so we're just like, okay, so Jenkins is still, okay, right? And one good thing about Jenkins being a giant XML tarball is we can back up the entire environment by tar gzipping the work directory and just like excluding the log data. And you get this huge tarball, and you can actually spin up a new Jenkins environment and extract the tarball and restart Jenkins, and your entire environment is reproduced, including like all your working nodes and all that kind of stuff. They automatically appear and reattach. And so it's kind of awesome for disaster recovery, but it's not super sophisticated for configuration. Yep.
Along the pipeline, and you mentioned before that ops is separate. And I'm curious, when things pop out at the end of your scaling tests, your package is ready to go, what's the process between there and the actual release, and how much sort of ops and other groups utilize Jenkins as well, or there's something that pops out the other end for them?
So our ops team is not involved in the release cycle at that level. They do not have to actually do anything, which is what we want. As long as the network is up and the power's on, for the most part, we don't need ops to do anything. We're past where we needed their help. We need to help if things break, but our whole idea is that we don't bug them about stuff. The pipeline, by the time we get to scale testing, we have packages that we suspect will be the ones we release, because scale test is time consuming and expensive. Like whenever we do a scale test in EC2, it's a good $10,000 or $12,000, right? And it takes a while to set it up. So what we do is our release people build the packages that we think are going to be the good ones, that we think we're going to make it through, and we run it through that like acceptance testing, like the install only test, and then our acceptance level test and our UI test pipeline. And once we get to the bottom of that pipeline, then we do scale tests, and we're theoretically ready to release, although we do some spot checking on certain UI features that are new and we suspect might have edge cases, because it's really hard to write Selenium tests to account for new behavior, right? So there's a little bit of that at the end, but mostly when we get to the end of that pipeline, the packages that started at the beginning of the pipeline, they get pushed out automatically to like EC2, so they wind up in EC2. We publish them internally so that developers and other people, like our professional services people, can grab the new builds, install them, and this is like all done automatically. We just promote those builds. So, yeah. Yes?
Do you run any code coverage tools to determine the effectiveness of your tests?
Do we run code coverage tools to determine the effectiveness of our tests? No, we don't. We have looked at this. We see lots of really pretty graphs and neat things, and we actually had one that we ran, and it gave us like an amazing report about code coverage, and we knew it was complete rubbish. And we're like, okay, we don't have time for this, actually. And I'm not saying you shouldn't do that. You probably should. We are not doing that right now. We have a lot of tests. I think we have like 60,000 unit tests or something crazy like this. Stuff still slips by. And we have hundreds of acceptance tests. And I don't really even know how many UI tests we have anymore. I don't look at the UI stuff all that often, to be totally honest. But it's probably in the like hundreds range now as well, or will be soon. So, yep. Pierre? Oh.
One last question before we...
No? One more. Oh, do we have to deal with mobile tests? At the moment, no. But our product our UI design people are actually doing mock-ups on that. I don't even really want to actually think about that right now because I actually know people who do that, and I think it's actually fairly hard. So, not yet, thankfully. So, cool. Wow. Thank you, everybody. I appreciate all the questions. It was awesome.
So thanks, Dominic. And I don't know, you're available for maybe if people have questions, or I'm sure you can get his contact information. So thanks, Puppet and Dominic, for hosting tonight. We have surveys. I think the forms are on the tables. You can grab one, fill them out, put your name, and we have a drawing for a bottle of wine. So if you give your survey, put your name and give those to Carrie back there, she'll draw the, when she got all of those surveys, you might win a bottle of wine. Again, I want to thank our sponsor, Rally, Salesforce.com, and Jenkins. We have a few events that are coming up. So let me see, April 25th, the Oregon Technology Awards program, and that's going to be at the Portland Art Museum. So, put it on your calendar. And there's another event, May 16, Tech Ignite. And we're doing more event, the QA Forum and TAO. There's always a bunch of events where you can go to the site TAO. What is the URL? Yeah. So go to the website. I think you can see what we have in the pipeline there. I'm sure there's a lot of cool events coming up. So thanks again for coming. And like I said, if you have, there's I think leftover food and maybe more beer if you want to grab something. Thanks.
In case we didn't say earlier, Puppet is actively hiring. So come talk to me. Thank you.